Hello again. So you might have noticed I'm wearing the same clothes as I was in yesterday's video. Don't think that I'm nappy and I'm wearing the same clothes over and over. I'm just doing my second video right after my first one. So anyways, we're going to start the video again with something that I will stop doing after this lesson, which is remind you guys that you need to open up your ISN before you even get started and fill out your table of contents. All right, so remember, if you are unsure of what to put in your table of contents, then just go to the back of your foldable. The page numbers are here, and it's going to be 3 through 4. And then remember, your skill number comes from right here, number 2. And then your lesson title comes from right here, draw and determine angles. So once you're done with that, then go ahead and go to your words worth knowing. You can see this time I filled them out. Here's my 3 from skill 1, and then here's my 1 from skill 2. Make sure that you go and watch your vocabulary video. That's where I explain what this word means. So I won't labor as much over defining it now that we're in the lesson video. All right, so enough of that. I didn't want to spend too much time on it, but now I want to get to your foldables. So go ahead, and if you haven't already, fold it up and slice it if you slice. I don't. Some students do, some students don't. Doesn't really matter to me. Whatever suits you. So first we're going to start with the coterminal angles, since that's what your vocabulary video was about. Now, I already had you define it as an angle, 2 angles that have the same initial and terminal sides. Ignore this for a moment, okay? Just completely ignore it because this is math lingo. And we are going to learn it, but we're going to wait a second. And first, just do a visual representation of what coterminal angles are. So what I want to do right here is just draw an angle in standard position. And to be in standard position, hopefully 2 things come to your mind. 2 things. First, your vertex has to be at the origin. Second, your initial side has to be on the positive x-axis. If that isn't true, you're not in standard position, shame on you. That's bad. So now you're going to just draw any angle. We're going to do a positive angle. Okay, and I'm going to put the terminal side in the 3rd quadrant, right there. And I'm actually going to label this one with degrees. We're going to call this 225 degrees. Okay, so you can see how that's a little different. We don't have to put theta because we know how big the angle is. It's 225 degrees. And just so you know, that's exactly halfway between 180 and 270. All right, so now we have to actually draw a coterminal angle, which means they have the same initial side and terminal side. Well, dang, that's really easy to draw. Vertex at the origin, it has to look exactly the same. So just draw your initial side where it belongs on the positive x-axis, and then draw your terminal side exactly the same as well. Okay, but what makes this coterminal is it's not the same angle. They share those 2 similar rays in the same positions, but they're not exactly the same. This was a positive angle. What happens if we do a negative angle? Well, how big is this? Here comes a little bit of math, all right? Geometry tells us that a right angle is exactly 90 degrees. If you need to, you can kind of like show the math down here. But we've got 90 degrees for this 4th quadrant. And then this part, well, how big? I told you it was exactly half of this quadrant. Well, what's exactly half of 90? Well, that's 45. So this angle is, dun dun dun, 135 degrees big. But since it's in the negative direction, we call it negative 135 degrees. So you can see they're totally different angles, yet they look the same except for the direction that they're going. All right, believe it or not, there are infinitely many coterminal angles for any one positive angle. There's infinitely many, which is what all this mumbo jumbo is about. But first, let's do another positive angle that has the same initial and terminal sides. So another coterminal angle that's positive. So it's almost boring. You have to draw the same thing again. Okay, but this time, I told you it has to be positive. So we have to start out going this way. But if we stop there, it's going to be exactly the same. So you have to keep going. And we can't stop there because that's the initial side. We have to stop on the terminal side. So we go to the terminal side again. Stop there. How many degrees around did we go? Again, here's a little math for you. We went around 360 degrees right here. I'll even show you, I'll even highlight it to help you out. 360 degrees right there. 360. And then the rest of it, well, we already know how big this is. This right here is exactly the same as this right here. So it's 225. So this angle is positive, but it's huge. It's actually 585 degrees. So you can see it's not exactly the same, but they share the same initial and terminal sides. All three of them do. So these are all three coterminal, all three different. Now for the math mumbo jumbo. Okay, so this is the formal definition. In mathematics, we have layman's terms, and then we have formal definitions. In trig, you're going to start learning formal definitions. So for coterminal angles to be, you have an angle of x degrees is coterminal with angles of x degrees plus k times 360, where k is an integer. So k is just some number. Hopefully you know that from Algebra 2. An integer is just a number, positive or negative. Integers are positive or negative. So an angle x, like this one right here, is coterminal with any angle equal to this. You can just plug in some random k. All right, so let me bring this home for you. This is our 225 degree angle. It's coterminal with something that's 225 degrees plus a number times 360. Well, what integer did we use to get negative 135? Well, negative 1. Voila, it fits the definition. All right, let's go to this one. Take our original angle, 225 degrees, and this time we're going to add some number times 360. This time, what's our missing number? Well, hopefully you realize it's positive 1. Now, what this does for us is it gives us a formula. We can create a million different coterminal angles just by plugging in a number here. If we wanted a positive coterminal angle higher than this, we just add 360 onto it. Or in other words, we put a 2 in here. And we say 2 times 360 plus 225. All right, so if that doesn't make a whole lot of sense right now, we're going to work on it more tomorrow in class. But that's the general idea of the formal definition. Now let's move on to something that you've done a million times since middle school. And you did it in geometry and algebra 2. No, probably not algebra 2. Maybe. Complementary and supplementary angles. Supplementary is AKA, say it with me, notice the S, a straight angle. That's how you remember it. Okay, so complementary angles, if you go inside, I didn't even have you write the definition because it's been drilled in your heads. Complementary is 90 and supplementary is 180. And don't forget, these angles are angles that add up to, or their sum is 90 and 180. So if we want to draw some pictures, well, we can just draw a right angle and then divide it in two and say these two angles, 1 and 2, are supplementary. In geometry, you might have said the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So we could put anything in there. If we make the measure of angle 1 30 degrees, then that means the complementary angle has to be 60, and so on. Same thing for supplementary angles, except they're straight angles. So that means their sum is 180 degrees. So you can just take a straight line and divide it into two angles, angles 1 and 2. And in geometry, you probably wrote an equation like this. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. So say I tell you the measure of angle 2 is 45 degrees. Well, then you can set up an equation and solve. And we know that x has to equal 135 degrees. And that's it. All right, so now what I want you guys to do is pause this video. If you need to, go ahead and glue it in. And we're going to do a practice problem. Oh, shame on Mrs. Watson. I did not label my lesson before I got started. That is very bad. So I'm going to take a moment to go ahead and at least put number 2 on there and remedy that after the video. So glue this sucker in right here, wherever. If you do it on the left always, or if you do it on the right always, remember, just stay consistent. Now underneath your foldable is where we're going to do our practice problems. Leave that other page blank for tomorrow. And we're going to do 2 practice problems. The first one, is I want you to find a positive angle. So write this down. Find a positive angle less than 360 degrees that is coterminal with negative 150 degrees. Okay, so how do we do that? We talked about coterminal angles, but how do we actually solve this problem? I mean, going from learning something to applying it is difficult sometimes. So find a positive angle, all right? So it can have a negative in front of it. Less than 360 degrees, okay, that is coterminal with negative 150 degrees. So there's some different things we could do here. You could draw it. I mean, you could draw negative 150 degrees. It's like somewhere right over here. And then you could figure out what the positive angle is that's the same as that. Or if you don't think much in visuals, then maybe you think more analytically. Maybe you would rather set up an equation. And that's what we're really kind of leaning towards in trig. So we can use this formal definition to help us out. Okay, what we're going to do is we're going to say, okay, we've got negative 150 degrees. Now to get a coterminal angle, we need to add some number plus 360 to get our criteria, a positive angle less than 360 degrees. So what can we plug in here to get a positive number less than 360? Okay, well, how about 1? Do the math. Does it work? 210 degrees. Yeah, it does. And that's it. That's all you do. If you do it visually, then you're going to think to yourself, okay, I have a full circle here. This is 150 degrees of it. 360 minus 150, what's left behind? 210. That's how big this positive angle is. But this is going to help you when you start to get into more complex ones like we will tomorrow. All right, second question and the last one for tonight is find the complement and supplement of 111 degrees. Okay, so first of all, to do this, we need to remember what complement is. So if you don't know it, you need to look at your definition. So complements are two angles that add up to 90 degrees. So one of our degrees is 111, or one of our angles is 111, plus some unknown angle has to equal 90 degrees. Well, wait a second. If we solve this equation, the only thing possible is a negative angle. However, I don't know if you guys remember, but in geometry, did you ever work with negative angles? No. You can't tell me that you can draw a right angle and somehow squeeze 111 degrees in it and then negative 21. So if you get a negative for a complement, it's wrong. Okay, not right. In geometry, we don't have negative angles. In trig, we do. Okay, and then supplement. Okay, so again, start with 111 degrees. We're going to add some unknown, and when you add them together, you're going to get a straight line. Well, that's 180 degrees. So here, if you do the math, that's going to be 69. That's positive, so that one does have a supplement. All right, so that's it. Good luck with making sure that you understand everything that I taught tonight. And just so you know, if anything didn't make sense, you're welcome to go to pages 442 through 443 in the book. Or you can always go to my Twitter. I forgot to mention that in the last video. _sassy_lemon. And if you catch me at a good time, I might be able to help you out then understand something. If not, you can ask me questions in class tomorrow. Peace.